Have you ever looked at the sky and thought, how does a cloud that big not fall? Its contents are water, even millions of liters. In this story, we'll uncover unique facts about clouds, from how they float to the secrets behind rain and lightning. Ready? Let's go up to the sky together. Have you ever looked at a huge cloud in the sky and thought, that looks so heavy, why doesn't it fall? Clouds look soft, but they're made of water. A lot of water. Strange but true, they never come crashing down on our heads. Actually, clouds aren't giant cotton balls. Clouds form from millions of super tiny water droplets and ice crystals. They're so small individually that they hardly feel heavy. The thing is, they gather together in huge numbers in the sky. Well, this is where nature's trick comes in. The water droplets in a cloud are microscopic, smaller than the tip of a hair. Because they're so small, the gravitational force pulling them down is also small, so they can float in the air for a long time. It turns out air isn't empty space. There are pushes from above and below. These upward air currents help support the cloud. As long as there's an upward push, the cloud is safe chilling in the sky. Think of a cloud like fine dust in a room. Dust can float for a long time because it's light and gets carried by air movement. Clouds are the same, just a giant, super cold version. So it's not magic, it's physics. So why does rain fall? Because the water droplets in the cloud collide and become bigger. When they get too heavy, the air currents can no longer hold them up. Finally, down it comes as rain. As long as the water droplets stay small, they're safe. But when they merge into big drops, gravity wins. That's the moment the cloud surrenders and starts dramatically releasing its contents to Earth. Clouds also have different types. Some are thin, some are thick. Cumulonimbus clouds, for example, are very heavy and tall, but they can still float because the air currents inside them are super strong, like a natural elevator. Inside a storm cloud, air rises at high speed. This air keeps pushing water droplets upward. That's why clouds can grow big and dark without immediately falling. Their contents are busy swirling around inside. Temperature also plays a role. Warm air is lighter and rises, carrying water vapor. As it rises and cools, this vapor turns into clouds. As long as this process is stable, the cloud remains suspended nicely in the sky. So don't imagine a cloud as one solid object. A cloud is a collection of small particles moving together. If one droplet falls, the others can still hold on, because the system relies on the collective, not individuals. The sky is like a big stage with many actors: wind, temperature, air pressure, and gravity. Clouds just play their part in the middle of it all. As long as the other actors are balanced, the cloud won't fall. That's why clouds can appear still, even though they're constantly moving. They shift slowly, rise and fall a bit, while waiting for the right moment to turn into rain. Patient, but certain. Sometimes clouds look very heavy and low, as if they're about to fall. That's a sign the water droplets are starting to grow bigger, just waiting for the moment when gravity says, okay, now it's your turn to come down. Interestingly, a single cloud can hold millions of liters of water, but it can still float for hours. This proves that particle size is more important than total weight when talking about floating or falling. If a cloud fell all at once, Earth would be chaos. Luckily, nature has a neat system. Water is released slowly through rain, drizzle, or snow. Everything has its order. So next time you look at a cloud, don't just think about how aesthetic it is. Behind its calm appearance, there's a physics battle between rising and falling, light and heavy, patience and descent. We've only covered why clouds can stay up. But there are still fun questions. Why are clouds shaped differently? And how can they suddenly turn into heavy rain? The answer connects to more complicated processes inside the cloud. There are collisions, rotations, even tiny wars between water and ice particles invisible to the eye. In the next story, we'll go deeper into the cloud's kitchen, from the process of rain and storms to why clouds can create lightning. So stay tuned, the sky hasn't finished its story yet. In the previous story, clouds looked calm, but their insides were busy. Now let's go deeper. Inside a cloud, water droplets aren't still. They chase, collide, and merge with each other. Like a tiny commotion you never see. When small droplets collide, they can merge into larger ones. This process is called coalescence. The more collisions, the bigger they grow. And the bigger they get, the harder it is for the cloud to keep them floating. Besides water, clouds also contain ice crystals. In cold temperatures, water vapor prefers to stick to ice. The ice grows faster, becoming heavier. Once heavy enough, it starts to fall while melting into rain. In storm clouds, upward and downward, air currents happen simultaneously. Some are pushed up, some are pulled down. This is why clouds can live a long time before finally releasing heavy rain. Sometimes water droplets are about to fall but get pushed back up again. Up and down, up and down. This process makes droplets even larger, until finally gravity wins decisively and the rain pours down. Lightning is also born from this chaos. The friction between ice and water causes electrical charges to separate. When the charge difference gets too great, boom! Lightning strikes. So clouds aren't just heavy, they're also full of energy. That's why dark clouds often make us nervous. The dark color means the cloud is thick and dense. Sunlight has trouble penetrating. Usually, this is a sign the cloud's contents are ready to fall to Earth. Interestingly, clouds never fall as a whole cloud. Only their small contents descend: rain, snow, or hail. The cloud itself stays above, changes shape, then slowly disappears. After rain falls, the cloud can thin out. Its contents decrease, making it lighter. Eventually, the cloud breaks apart and evaporates again. The water that fell can rise again someday. The cycle keeps turning. This is called the water cycle. Water from the sea evaporates, becomes a cloud, falls as rain, then returns to the sea. Clouds are just a brief stop in the sky before continuing their long journey. So if you think clouds don't fall, actually, clouds are smart at waiting for the right time. They hold back until conditions are just right. Once the timing is perfect, they release their contents without hesitation. Wind is also an important factor. Wind can shift clouds to other places. That's why rain can fall far from where the cloud formed. Clouds are air travelers. Sometimes clouds look very low, as if you could touch them. But still, they don't fall, because even though they're close, the droplets are still small and are still held up by air currents from below. If a cloud truly fell as one solid object, Earth would get a tsunami from the sky. Luckily, nature works in detail and with patience. Everything is released gradually, according to the Earth's ability to receive it. Clouds teach one important lesson: looking heavy doesn't mean you have to fall. As long as there is support and balance, something can last longer than we think. That's why the physics of nature is amazing. Without engines, without cables, clouds can float, move, and even store that much water. All using only consistent natural laws. Now, every time you see a cloud, you know, behind its cute or dark shape, there's a complex system at work, not just passing through the sky. Clouds aren't failed falling objects. They are the result of balance. Once that balance is lost, that's when rain falls as a sign of change. So the answer to why clouds don't fall to Earth is simple yet profound, because they're not ready yet. And nature knows exactly when it's time to let go. Next time you get caught in the rain, remember one thing: that's not a cloud falling. That's a cloud sharing its contents. And after that, it will leave, waiting for its turn to be born again in the sky. And if you like stories like this or are interested in similar topics, don't forget to subscribe to this channel. By subscribing, you won't miss out on other exciting content. In the next video, there will be an even more interesting topic. It could be more mysterious, more entertaining, or even more surprising than you imagined. Don't forget to turn on the notification bell to stay updated. Likes and comments also help this channel grow. Thanks for watching, and see you in the next video.